Great. Thank you so much, Natalia. Always a pleasure to have you. And dear panelists, welcome again formally to this great session. We are really looking forward to the deep insights that each of you can add through your multiple years of experience in this particular space. So with that, what we will do is I will start with a quick icebreaker session. It is to allow the audience to, to understand each of you a little better. And I would like to start with, Dominique. Dominique, welcome again. Dominique, as you have seen, connectivity is really accelerating the use case adoption within the automotive industry. As the industry drives towards autonomous, connected, electric, connected especially, is expected to significantly simplify our lives. You are closely associated with the connected and autonomous space for automotive players, especially in your current stint as the Director of Innovation at TE. Can you please share some highlights of your overall journey and also on what problems are you really looking to solve currently?
Hello, Zidan. Thank you for the invitation to be part of this panel today. I would like to briefly start highlighting my journey when I established the Silicon Valley tech office of TE Automotive back in 2015. At this time, Silicon Valley had a number of up and coming players, new players in the automotive industry. And for us, this really was an eye-opening moment to see how these people think and how they act, much different than, let's say, established OEMs or tier ones. They come with a different background. A lot of them had no automotive prior experience. They came either from a consumer industry or datacom industry, very much with the software mindset. And you could tell this difference in approaching this automotive industry was for us quite a challenge in the beginning. Within TE, we also have a data and consumer business, so we could at least speak their language, but it was difficult when it came to, let's say, connectivity solutions. All of a sudden, you needed automotive qualification, automotive robustness, right? There is a different lifetime expected behavior. Protocols were different, standards were not quite there. So these are a few challenges that we had to address with when we engaged with all these new players. I think that's very well known, the difference in speed of some of these new players with the established ecosystem.
Excellent, Dominic. So it's very interesting that you mentioned 2015 and Bay Area. I remember exactly in 2015, we were having a conversation with one of the largest tier ones in automotive, and they told us they don't even have an internal title called software engineer. So I'm sure you have taken a lot of pains to actually build software into this particular ecosystem. Great. We really look forward to hearing a lot more from you as we move into the next section. But before that, I would like to welcome Yves Antoine. Hi, Yves. I hope you're doing well. So the question for you is, you have been in the heart of the automotive world in Germany, in Munich, for more than about 2 decades, right? And you have witnessed the automotive ecosystem very closely over these years, and you have also seen the changing dynamics very closely. How have you seen the evolution and adoption of software specifically within the connected and intelligent car ecosystem?
Thanks, Vedant. So software and connectivity, to be honest, is, in my view, nothing completely new for the automotive industry. So software, especially the companies, tier one OEMs, are dealing with this since decades. What is really changing now is more the strength of the connectivity, the volume of things that you can exchange with other people. This is really the main change that we are experimenting today, where you move from a car, which is a system itself, to a new structure where you can have the car as part of a larger systems. And this is where you are really moving out of a very integrated systems where every product is optimized to be a product that will stay within the car over years, sometimes decades. And you are moving to a completely new structure where you can think about new features, new functionality that you have in other domains like telecommunication. And you need to change completely your way of thinking. And this is, in my view, today, one of the main challenges that all the automotive industry is facing, because this way of thinking will change not only the products that you can put on the market, but also the way of working together. It will also change deeply the way of preparing a project, the way of thinking about the life cycle of your vehicle. And this is something which is really very interesting to observe. All the new options that are coming up now, all the new options for existing people in the automotive industry, but also all the new options for companies that were never dealing with the automotive industry and that are now getting the chance to also start their journey there. And I think it will also offer and change a lot the way we are operating in the automotive industry, with less way of thinking in terms of proprietary way, in terms of being only focused on his own products, but having a very large ecosystems that you need to manage in a different way than in the past. So I'm really excited about the future. For me, SDV is not only a technical change. This is really a big change in the way of operating the automotive industry for the future. So looking forward to the future.
Great, absolutely. Thank you so much, Yves. Those were very insightful comments, and we will build on that. I will come to you, Bernd, right now. And so, Bernd, you have been, again, more than 2 decades of experience working across telecom space, working also closely with the automotive world. In your view, Bernd, as you look at the evolution of, how telecom services and the automotive world is interacting, what is, according to you, the vision for the next generation of connected vehicles and also the services alongside them?
Yes, thank you very much. Thank you for speaking at that event here. Thanks for all of you listening and sharing your ideas. I mean, I came to the telco industry 25 years ago. It was actually during the first commercial launch of mobile networks. And I think at that time it was all about telephony and what to do with it. At the time then, as we know, UMTS changed completely. There was high investments. There was auctions from the states where magic frequencies should bring the fortune of every telco. At that time, I think we were looking for the incredibly about the killer application. So an application that really would consume the bandwidth that we would have available. And at the time, it was very small bandwidth. And then we all know when the first smartphone came, was a fully configurable device for everybody in their hands. So something completely different to what have been there before. And when you now look at converting that to the car industry and the advances the telco industry made with the introduction of 5th generation networks and also future 6th generation networks with endless bandwidth, and with the car being more or less the mobile handset, gives the car industry a completely new product. Yeah, one is, as everybody says, it's about autonomous driving, and we all know you need a lot of data that is transferred back and forth to the car for autonomous driving. But it also, the car is now the mobile headset, and so the car can be updated over the air with every new functionality ad hoc, and I think there's a completely new way of thinking. So it's much more like a pay-as-you-go model. So assuming, and I know the car industry is working on it, assuming your motor, your engine is probably have 200 PS, yeah, you can change it, and you can by a mouse click adding 50 PS more if you want, or you can add more into the entertainment set, or more in the security space. So you probably can buy a base car and then you upgrade it over the time. And so this also offers a full range of new commercial models for the automotive industry. Yeah. And I think that we will see a lot to come. when it comes to telcos, I mean, we all there to support this industry. And if you look at the connected car, it's really much a connected ecosystem. And so it's an ecosystem of an in-car software, which is more or less the primary edge. And then you need to connect it to a backend somehow, and it should be over the air and then to a backend application. The backend application would then reside either in a mobile operator's data center, at an edge of the car manufacturer, or even in the cloud. Yeah. And
Perfect.
And then you have security. And we all know some of that traffic needs to flow via public environments. And so security is one of the big factor, because it's not only about the security of the car itself, it's about the privacy of the user of the car, and so on and so forth. And we all know that security is one of the biggest hurdles for new digital environments. So how we support as telcos is security in the car and at the edge, then definitely anything around radio access, 4G, 5G, 6G coming along, hopefully soon. And then anything about the backend. Yeah? And the backend is connecting to the mobile operators, to the cloud, but also to applications that come probably from manufacturers, but also from the wide ecosystem, from partners, from technology partners, from tier 1 OEMs in the car industry. They all need to connect it to make that car really a living environment. Yeah?
Interesting.
And this is very much what we try to support, and the telco industry as an open communication industry between all kinds of ecosystem partners. Thanks.
Thank you, Bernd, for those interesting comments. I really liked how you said that just as you can increase or throttle the bandwidth, can you increase or throttle the power of a car? So I can buy a Ford and maybe it becomes a Ferrari sometimes.
Yeah.
If I pay enough for it.
As soon as the hardware is capable of doing that.
Exactly. Great. Peter, I'll come to you now. So we've all imagining very interesting futures for the car and the overall ecosystem. At the same time, one of the most complex and difficult issues is on the actual infrastructure that is needed, especially charging infrastructure. And you have been trying to solve that problem through smart and intelligent charging facilities in OM as the mobility director. So could you please give us a view on how you have seen the EV charging players evolve, and how are they really trying to address the new, what Eve, like you mentioned, software-defined vehicle revolution?
Thank you very much, and thank you very much for the opportunity to speak, obviously. I think when framing, obviously there's going to be a huge demand in the electrification space around charging facilities, and different markets are at different speeds, but whatever's going to happen, there's going to be a huge demand for these services. I think it's worth framing that they're in two very different categories. There's one around public charging, and that is the ability to charge on the go somewhere. And that is where today the majority of OEMs are investing their efforts. And you see big investments in public infrastructure. And they are primarily there because we are still dealing with early adopters. We are still dealing with people who are making the transition from a combustion engine vehicle to an EV. And they see how obvious BP and Shell service stations are in every market and how accessible they are. And they think at that stage they need something just as accessible for their EV. So to adopt an EV, they say, I need lots and lots of public charging to be available. So significant investment in public charging is occurring. And that is often about land rights, building infrastructure on property, often quite significant grid upgrades to make those sorts of major charging facilities. They're big investments in the energy grid in their own right. So there's a big public charging activity, and the car will interface into those public charging facilities to give people convenience on the go. But that is one aspect. The other big aspect is residential charging. So it does differ a little bit by market, because some markets have more prevalent off-road parking on at consumers' households than others. But the majority of houses globally, in mature markets to begin with, will have that capability of having the ability to charge at home or on the consumer's doorstep. If that can occur, then the energy through a household is going to be cheaper and lower CO2 than public charging will be, because the car can have this integration into the energy grid. The car, through devices like our own, can identify what is the vehicle and what's the state of charge. What's the customer's tariff, so we know when it might be cheaper or, for instance, on their tariff. And the third thing we can understand is their commute schedule. And with the combination of those factors, we are able to charge a car when good for the grid. And in fact, organizations like ourselves are integrating with energy providers to give them demand. Here is a vehicle. It's parked on this person's driveway. It's probably not going to be used again until 7 o'clock tomorrow morning. It needs 20 kilowatt hours. You plan where those 20 kilowatt hours occur. And therefore, the energy supplier is in a position where they've got certain demand and they can schedule it when it's good for them. Rather than, in a public charging environment, you just need your car charged immediately. And your fridge always needs to be turned on. But the car can have integration with type of use tariffs, where the demand is shared with the energy grid. The energy grid knows that demand has to turn on. And actually, that's where the vehicle is, as opposed to this location devices that are being built energy chargers, it's actually more about integration into the household electricity system and the energy grid at whole in that market, all of which will be slightly different. But this ability to provide demand side response, this ability for smart scheduling, or the big risk here is we need a lot more copper and a lot more electricity generation. What we're able to do is give the energy supplier the ability to schedule that charge to occur when it's good for them. So I guess in short, your answer, there's really two different domains, public and residential. We think residential is going to be where the majority of charging occurs, and the integrations will be quite different between those two different categories.
Interesting, Peter. We're really watching closely as to how this really evolves. Hopefully, there would be some wireless charging on the road as we move as well soon. Great. So I would now get into the second section where we have certain detailed questions where our speakers can add more insights on specific areas. And I'll come to Dominic first. Dominic, the first question I have for you in this section is, as you have witnessed, there are multiple changes, evolutions, almost revolutions that are going on in the automotive space from the energy, connectivity, UI, UX, and scalability perspective. And obviously, software is at the core of all of these. What are your views on how the R&D ecosystem is trying to catch up? What are some of the things that you are trying to do to inject a lot more software into the system? Maybe you can build on the example that you gave on how you set it up in 2015, etc. But some more color on how to actually get this ecosystem going in the automotive space from a software perspective.
So first, I would say there are, besides the software, the change of the architecture is one of the main big changes that is happening right now, which is, yes, related to software, but also, the harness itself was already quite complex to begin with a lot of point-to-point connection. And in the efforts to try to automate it, to try to make it lighter, making the car more sustainable, getting weight out, removing some of these cabling, there was already the push for simplification and consolidation. And definitely with software, we see this much more. You don't want to have too many ECUs, the electronic control units in the car, that if you try to update something or if you try to add something, you keep on adding things to this massive spaghetti bowl that you already have in there. So the simplification in architecture together with added software but also at the same time increasing push for automation, simplification. This all has a major change in how some of the R&D development happens right now. And for us, definitely, I think the change you also see is if you have a phone and you think of the software, you have maybe a life cycle of 2 years. At least I think most phones are kind of built for 2 years, which is very different from the automotive industry where things are supposed to last a lot longer. And I think especially when it comes to battery electric vehicles with less parts, less moving parts, you can have lifetimes that are much longer than I think even the typical 10 years. So how do you design the connectivity solutions that even throughout these update cycles with software, you can still keep your hardware going? So you definitely see now the change for designing scalable and modular connectivity solutions that can live throughout many different software cycles.
Interesting. Yeah, interesting, Dominic. I'm sure it's a complex world, and we're all learning how to keep up with it. My second question is for you, Bernd, and again, this is more in terms of the growing complexity, and also considering that a lot of the components and parts and the way we think about a car is very associated with safety, and not the cyber safety, but overall personnel safety in itself. And now there is a plethora of activity going on in terms of connected services. All of this is putting a lot of pressure on the telecom industry as well, maybe in terms of reliability, in terms of latency, etc. So what is the key evolution that you are seeing in the telecom and maybe the telecom cloud space in terms of how you're trying to address some of these concerns and also the needs of the next generation connected car?
Yes, yeah. You mentioned already a lot of those challenges and opportunities. I mean, the world is really indeed getting much more complex. And if you look at the car application from the car, it now interacts with a lot of platforms. And this is really a multi-platform, multi-cloud play now. And this is all happening in real time. And the cloud is today not only one application. Yeah? And the security of the network and the overall travel of data is so much important. And so as I mentioned before, you have this security at the car edge, you have the security overall for the connectivity, and you have to connect to various applications that are somewhere in the internet or somewhere in a private network. And we recently see examples of failures, and some of these failures, if you're not in a car, probably don't worry you so much. If you cannot access Google for 5 minutes, you wouldn't worry. In a connected car that really needs to drive in real time, this is a severe problem. Yeah. And we, for instance, saw recent examples where infrastructure failed, where internet, for instance, was not available because of a failure in a content delivery platform that nobody thought about, because it was a platform that was controlled by a third party, which is probably not so much obvious to neither the customer nor us as a telco. Yeah. And then the other big action is really security concerns. And we see that the number of cyber attacks is growing year by year. Currently, we have a growth rate of 240% year on year of additional cyber attacks coming. And we saw very recently an outage of the Google Edge platform in the States because of data had been compromised. The data had then flown into China, for instance. Yeah. And then also using a Russian network and an African network. So the way the internet was designed, I mean, the internet was never designed as being a highly secure private platform where you could operate an autonomous car on it. Yeah. So it's massive what we really need to look at. It's massive, the attacks onto the the public networks. And it's very unlikely that customers do not get attacked over time. I mean, there was this moment where the ex-Cisco CEO said there's only two sorts of customers. One, they have been attacked already, and the other that don't know. Yeah. And so there's tremendous investments, I think, for all the parties to be made on security. And we also need to look at the architecture of all of that. And due to the more and more internet-friendly architectures of new software stacks, the number of vulnerabilities becomes more obvious. And if you then add the recent geopolitical crisis, like the Russian-Ukraine war, the political issues with China, this put much more additional risk on the network and also on the internet. And so it's our big responsibility as telco ecosystem partner to manage the service that spans over this multiple platform, to secure to our customers a seamless and secure connectivity to this all ever growing ecosystem. And what we are doing in detail is, on the one hand, we are investing a lot in modern telemetry and monitoring systems, really to find out these gaps and to make it visible where traffic really flows in good times and where it also flows in bad times. Yeah. And you'll be surprised if you look at a simple application on your laptop with how many sources this application nowadays connects, to get their service. So this is one thing, all the visibility stuff, the telemetry stuff. Then we carefully discuss with the customers about carefully selecting private and public networks. There's definitely, at the edge, you don't have a private network usually, so you can only use public networks. But the more you come to the back end, you carefully need to look at. And what we look at to connect private and public networks with low latency to any backend that we have, either in a public cloud or in a private data center of either the car manufacturer or the car manufacturer's ecosystem. And then definitely a major investment in security. And for us as a telco, it's our lifeblood, because if we are not trusted as a communication provider, whom else to trust? And so all the telcos, I think the whole industry has invested massively in security that has two major tasks. One is protecting the telco itself against attacks, and this is really very important to us. And then securing our clients on that. And so there's in many of our partners and ecosystem, it's the same team that really looks at protecting ourselves and protecting the customers. And the last thing I think where we're investing heavily is the whole telco architecture became much more cloud-centric. Yeah, because before that, I think the network that the telcos built was very much historic. It was where customers were, where probably consumers were. But now it's, again, how to become cloud-centric, putting the network close to the cloud, reducing the latency, improving the security. And this is all paired by modern software-defined architectures, so that you can really manage, configure effectively, and have high agility of the service to look at. I think these are the major investments that the telcos do in order to support the automotive industry, and not only the automotive industry, definitely, because this is equally important for banks and for big manufacturers that have their machines online and so on and so forth. So a lot of good things happening in that industry.
Thank you. I think, Bert, that was very detailed, but at the same time very insightful. You mentioned three very clear challenges. Firstly, in terms of data. Second, in terms of security. Third is in terms of cloud and the challenges that come associated with it. So I think we will discuss each of these a little more, and I think the audience also would like some answers on the security part, and we will weave that into what we discuss now. I will come to Eve. Eve, what I wanted to understand is just as Bert mentioned and Dominic before that kind of hinted at. The automotive players are now working with increasing amounts of data, right? And the amount of data that they capture, right, from customer data to machine data, and the way it gets consumed is also very different. It gets consumed by insurance companies. It gets consumed by the OEMs themselves. So, can you share your thoughts from your perspective on working with multiple companies on how the ecosystem players are managing the scalability of this, right? The amount of data just keeps increasing. So how do you manage that?
So behind that question, there is, in my view, a very first question is, do we need to manage that much data? Okay, if you have a look at companies that are already managing this, the first way they are dealing with is how to reduce the volume of data that you need to manage and to store. They are not trying to manage everything. They are trying to define how to capture the right ones and how to secure that you are improving your knowledge based on what is really occurring in a car or elsewhere. So I think one of the key parts in the ecosystem, and this is also one of the key advantage if you are having a SDV, that means you can upgrade your car, you can update your software. That means you don't need from the beginning to store every kind of data. You can change it in the future. The only things that you need to make sure that you have the sensors and you have the information existing in the car. But afterwards, I think one of the key elements within the ecosystem is that they will help through OTA and updating the software to have the right way to identify and to monitor the data in the system. And once you have this data identified in the right way, then you can save them, then you can transfer them to the rest of the cloud, and you can work on this. But I think the key element is really to work on AI, to work on this specific patterns to define which are the relevant and the useful data that you want to have. And only after that, try to store this. This will also be for the future something that, in my view, that will change a lot, because you can have also a dynamic way of managing your data within the car. So this is something that can be, for example, related to a business case. It can be also something that will be defined by the user himself or by different companies. And this will be, in my view, something very dynamic. The only thing that will not work is trying to store everything every time. I think this will not be the right way to manage it.
Interesting. So you're talking about on-demand data management almost.
On-demand data management plus an intelligence strategy about how defining the right data to be stored at the right time. So if you are driving your car, in 99% of the times, nothing interesting is happening. Okay, you have only maybe 1% of the time where something useful for thermal analysis is happening. And one of the key elements for the future will be to define what is this 1%, and then to start to collect data and to send them to the appropriate place. But not to try to collect 99 or 100% of the time all kind of data without any usage for that.
Interesting. I just wish Apple and Google did the same with our phones. Great. So, Dominic, I would come to you. You're the expert on this one, and you spent a lot of time defining data and the scalability issues. We would love to hear your thoughts on this.
Yeah, I definitely would agree to what Yves just said. We saw a huge demand for more and more data bandwidth back in like 2015, 2016, 2017. You know, the sensors were getting sharper, the megapixels, the chips, everything was, and people talked about this crazy bandwidth that they needed. At the same time, there was also what do you really need, right? I think we have to distinguish between the beginning phase of where these systems were being built up, where you were trying to figure out what do you actually need, same what Yves said. And then we saw already also this kind of little going downward. Do we actually can get away with less? We also see startups and solutions that said, let's compress things, let's become more selective. So yeah, you definitely see all this. Maybe there is just a different use case when you have a fleet provider, right? Then it might be different. But I think it's very much a difference. You have a personal car or you have a fleet provider. Are you doing R&D, developing a new system? Are you really trying to implement something? And I think there is this whole, let's focus on what's actually needed. Let's compress. Let's kind of be very picky on what we need. Yes, we definitely saw this in combination with startup solution to scale this whole system down that in the beginning seemed to be just blowing up.
Interesting. Thank you, Dominic. Peter, similar question to you. We all spoke about data and the different use cases and using data on demand, being selective, trying to compress. So from your perspective as an ecosystem player in the space, what kind of data is most interesting to you, and how are you trying to use it to make things a lot more efficient and better?
Thank you. Yeah, and I guess if I answer the question in two parts, because I still get back to there are two very different domains between the public charging, the destination charging, and what's going to occur at your home. In terms of that public destination charging, I think the consumer is going to want three things. They're going to want to search for something convenient, and ideally that the car or their phone helps them identify that based on where they're already traveling to, which is probably fed into the car. The second thing they're going to want to understand is the availability of that charging equipment. And certainly what we've experienced in the UK is some of the early equipment that was introduced ended up being quite unreliable. So just because a charger is there doesn't mean it's working. And then second of all, doesn't mean that it's actually freely available. It could be, a big long queue at it. So what the customer want to know is the ability, is that charger accessible? And maybe even in future, can I schedule it so it is available in 10 minutes time when I get there? And the third thing they're going to want to do is pay for it. And I think just within those three bits, it's more a question of who's going to win. So on the kind of the search functionality, you'd expect that Google and Apple and what you have in your phone is going to end up being very powerful. The scheduling and availability ends up being a network thing. It's more about which of these networks is able to collect the best data, because you're going to want to have the most regular use of understanding whether that charge is accessible or not. You don't want information that's 3 months old. You want information, the most recent. So there'll be a network play in there of who can get that data and build network effects from it. And then the third thing is about payment. And if I liken it to what happened in the UK on the underground, about 20 years ago, they introduced a thing called an Oyster card, and that was everyone applied to get a special card to pay for their transportation around London. It ends up being now you use your credit card, and in fact, most recently, people don't even carry their credit card around; they carry their phone. And I guess there's that piece around that public infrastructure as it becomes contactless. Do you need a special card or something in your car that pays for it? Because in fact, every consumer is going to have their phone, and their phone will just pay for the charger. So I guess there's those three bits and a debate around, does the car win or the phone win? Because a lot of this can be managed through that activity. So that's the public charging bit. In terms of the data around the home, consumers are going to want two things, we believe. Easy, simple is the first bit. And the second one is around cost. So they're going to want the simplest way to charge that vehicle with little, manual interaction. They don't want to set a timer or have to worry about when that charge is going on. They want to plug it in when they get home, unplug it when they leave. And therefore, the data about cost is more about grid integration. It's how does that car and charger integrate with the household electric system and then the grid itself. They're the big data plays in that space.
Interesting, Peter. I'm sure you're solving not so easy problems. So look forward to each of the solutions that you bring forth. Before we go to my next planned question, we have some interesting questions from the audience, and one specifically for Bernd. I think the audience is really excited about the concept you mentioned about adding more power to a car. So the question is twofold, I think. One is, firstly, do you think there is a way to get the regulators also aligned to this? Because obviously, if you do an OTA to get a better, higher power, is there a way to get a dual homologation kind of thing in the vehicle? Is that, I mean, is anyone considering that, or is it still very far off in your mind? I'm sure you ran into this in the telecom space as well, right? There could be, an approval for just X amount of bandwidth, but you have to improve. So any learnings that the auto space could have from that experience?
Yeah, I think it's a question of, this was probably extreme example. That's really the question was extreme examples. So the thing is, what does the regulator allow, and what is something that the regulator is probably not interested in having a new light ambience in the car, or having a better audio system, or having more entertainment is probably nothing what the regulator is interested. If it's anything around safety of the car, definitely, and this needs to be done, and probably also needs to be looked at by country. For instance, Mercedes-Benz, they now got allowed really layer 3 to layer 4 autonomous driving up to 50 kilometers an hour. So it was bound to the speed of the car, which means within the rural areas you probably cannot use it, but in a dense city traffic you can use that car and have a fully autonomous driving, and you can do your work or read your paper and things like that. And so I think this is where it's going, and the car industry is definitely in close dialogue with all the regulator bodies. What is allowed and what can really be upgraded over the air, what is security and safety reliant and whatnot. Yeah.
Interesting. Thanks, Bern. Eve, I know you have a point. Maybe I'll ask you a question, and you can start with the question that I had with Bernd and then detail out the next one. So my next question for you, Eve, was more in terms of your perspective of working with multiple automotive companies and even maybe different telecom companies. How do you believe, or how close do you believe they are in terms of aligning with this concept of software-defined vehicle? So that's the question. So maybe you can comment on the OTA and increasing the power first, and then get to this.
Okay, so somehow there is a clear link between both of the questions. What we almost always forgot to mention is that SDV is already existing. OTA is also already existing. Yeah. You have a small company called Tesla, which is having this since years. So everybody was focusing on the electrification part when Tesla was starting. But this is not the only disruption that was coming together with Tesla. They were also starting with OTA already. And they were already having a lot of strategy on this. So this is something that we don't have in mind, but they are already covering it. I think that they are making it with quite a lot of success. And in terms of certification, think also about the fact that even today, in most of the cars, you have some functionalities that are certified, but not delivered to the people until they are paying for that. This is nothing else than configuration management within a car. That means you can have a strategy today, meaning especially with electrification, you can have within your car a software-based strategy on the power you have in the car. You can certify your car with a maximal power and reduce it. Okay, so you will have a strategy of certification for this. This is something that I would say all the OEMs are already dealing with. They will have to adjust, of course. They will have to align to the regulations, but I'm more than confident that they will do it in a proper way.
Interesting.
For the other part of the questions, more dedicated to what is the current situations, I think today, all of the OEMs are dealing with SDV. So it was probably not the case 2 or 3 years back, but now I think all of them have to do it because this is that change and a disruptive change in the industry that if you are not moving in that direction, you will face some very hard issues in the coming years. The question today is more, what is the understanding of SDV? And then here you will see a huge gaps between the OEMs, between the tier ones. Some of them are still trying to find a way to keep legacy and to move smoothly in the SDV world. Some other ones are saying, okay, we are all telling that Tesla did the right things in starting with a greenfield. So let's stop to try to move our existing cars in SDV and let's restart from scratch with a complete new architecture. So this is a very hard call that some of the OEMs are doing, some others are not. And if you have a look at the SDV, within SDV, you have plenty of key functionalities existing. Some of the companies are dealing with all of them. So we were speaking about OTA. OTA, I think, is obvious. What about shadowing, which is a very important functionality within SDV, where less focus is existing today? Shadowing is nothing else than changing everything to test your car. Okay, you stop to test the car only with new products. You can also test live on a digital twin within your car, which is something which is also existing already today. Okay, what about containerization? Moving really to a cloud-native way of thinking. Moving out of the purely, I would say, classical embedded software way of thinking and moving to a broader way of thinking, meaning also that you will access to new talents that are not part of the automotive ecosystem today, but that are maybe part of the cloud-native ecosystem, of the telecommunication ecosystem. What about a vehicle-centric way of thinking? Do you need to stay with a vehicle-centric way of thinking, or do you come from the business case, from the use case? So Peter was referring to, for example, charging systems. So today you have companies that are developing cars or trucks coming from a complete other way of thinking. They are coming with a business case where the vehicle is part of the business case, and they are developing the vehicle as part of the business case, and not anymore as the car is the business case. And this is really what you see today on the market, that the maturity of the companies is quite different, and you have a huge gap between OEMs, tier one. Within their own structure, you can face all kinds of projects. And to be honest, I'm quite enthusiastic about SDV today, and I'm quite proud about what we are doing with Wipro, because we are part of many of these projects. I would say almost all the key ones. And this is really something that is very interesting to see the change in the automotive branch in all directions. Hardware, I also agree with Dominic on the fact that we are underestimating that a software-defined vehicle is starting from a new hardware infrastructure. If you want to be successful, you need to disaggregate hardware and software, and that means you need to change almost all your way of thinking in this. And this is really interesting. And then you are going up to the business cases. So this is really a huge change, and you see strong gap in the maturity there. And even companies that were starting quite early with SDV are somehow now late, because starting a little bit earlier in comparison to the other ones mean they made some choices that are not anymore the, I would say, actual choice or the right state of the art.
Right. Thank you so much, Yves. I think you mentioned quite a few areas, and I would love for Dominic to elaborate on some of them. You spoke about, how do you manage the coexistence of legacy and SDV. You kind of touched upon talent. I think it's a bigger issue than the time that we are spending on it right now. And you also spoke about how do you manage the use cases, vehicle-centric versus business-centric. Dominic, you're in the thick of things when we talk about SDV and the adoption. So please, your comments on the challenges and how best do you think we can resolve them?
There is also, when it comes to the hardware, the challenge of increased reliability. I was talking before about the longevity, but also the reliability. You need to really have a solid foundation, right? If you have any type of electrons that you lose in your connectivity, also your hardware, your software that builds on top, right, can shake. So it's really important, I think, the automation, not just for cost purposes, but also for reliability and making sure that you have absolutely reliable foundation that you build your software on top on. I think that sometimes get also forgotten.
Interesting. Thank you, Dominic. But a similar question to you. What do you think are the big challenges from your vantage point? I mean, just as you see multiple other players, you see them too. And what are the key things that the telecom world is trying to help out to increase the adoption of the software-defined vehicles?
Yeah, I think we discussed it before. The sheer volume of data, I think, is a major concern. And today, from all our partners, we see extreme volume of data, like terabytes of data from one vehicle being created. But remember, this is still early days because we are still in a phase of trialing out autonomous driving. And what the car manufacturers and the OEMs are currently trying to do is to pull as much information out of the car that's available. And for that, they ask for huge networks to transfer the data and to bring the data somewhere. And it all starts, for instance, with, let's say, after 1 day of autonomous driving, the car has about, I don't know, 10 or 100 terabyte of data. That's nothing what you can easily transfer via a network. So what they currently do is they take the hard disk out of the trial vehicle, bring that hard disk to the data center, or even work with a cloud provider, send it to the cloud provider and put it onto a server then so that they can work with it. And then the question is where the data is now being transferred geographically over the network, which all takes an endless amount of time. In future, I mean, if we really go into the operation mode, you have hopefully then smaller number of data that's created and needs to be put into clouds and external systems. But on the other hand, you have much more cars then. So the net effect on networks is more or less we expect the same, because you have instead of thousands of cars producing terabytes, you have millions of cars producing probably gigabytes or something like that. And I think what is also still early days is where really to process the data. And as also Yves, Antoine, and Dominic said, what do you do really in the car and where you can consume cloud ecosystems? And we all know from the mobile device example, is always the idea to put as much as possible into a cloud, because once you put it there, you only need to develop it once and then it's available for all the cars. If you try to develop something by car or by software variant within a car, you're always bound to the software variants you have. You recently heard about the issues that CARIAD from Volkswagen have in order to manage different software development trains here, because you have probably one piece of software that should come immediately, one piece of software that comes in 2 years, one piece of software that probably is more for luxury cars and one is more for consumer, and so on. And to avoid all of that, a cloud architecture would be the best thing to do. But on the other hand, you then have more data to transfer. And to have the data then somewhere managed, the whole industry is now looking at where to store the data effectively, and where to store it in the car, but also where to store it in edge data centers that are in the vicinity of where the data traffic lies. And this is a whole new industry, I think, from the car manufacturer, but also from the hyperscalers and the private clouds. We now see where the hyperscalers, for instance, invest heavily in the major countries in edge data centers. We saw AWS, for instance, not only investing in Frankfurt, for instance, they are now investing in Berlin, in Munich, in Stuttgart, and so on, to really bring a compute closer to the connected car and to the Industry 4.0. Then you have a carrier neutral facility, fabric providers that offer possibilities to store data in intermediate, more or less, between the car and the cloud, and to have low latency over there. And finally, it's also the commercial aspects of all of that, because we all know everything you put in the cloud is for free. Everything you take out of the cloud, you pay egress. And egress is also not so small, because per gigabyte, probably it's just a few cents. But if you add it then into terabytes and terabytes and terabytes, it becomes a big number. Yeah. So that's also where the whole ecosystem now works, hopefully friendly together to find the best solution where to store it. And so I think we are only at the beginning of a new data architecture, I think, for connected cars. Yeah, that's my point of view.
Interesting, Bernd. I actually have a couple of more areas to look at. Maybe I'll start with what I've got a couple of more requests from the audience to just spend some more time on the cybersecurity area, and maybe I'll have Peter come in first and Dominic after that on this area. So Peter, in the sense of data security, and also in terms of preventing any cyber attacks or ensuring that the data is not going to places that we don't want it to go, either from a geography wise or a place in the internet. How do you think the ecosystem players such as yourself, what role are you playing, and how are you trying to solve this this not so very easy challenge?
So you've got a really good panel that will answer that on behalf of the car. I might be better answering that on behalf of the grid.
Yeah.
And I guess if I give an example, many of the EV hubs that are being set up are rapid charging stations of 20, 30 or 40 rapid chargers put together. The energy upgrades required to make them work are often equivalent to, or in fact, I have experience of they're equal to the largest buildings in the UK. Largest skyscrapers in terms of the energy demand required into them. So you can imagine they're major pieces of national energy infrastructure. If you had a cyber attack on one of those, you could really expose some fragility in the grid. So I guess that's in the public space. And then if you think about, if you go forward and you say, the device which you charge your car through at your home is going to be smart. And it's going to be smart because you want grid integration to save the driver money. The driver's going to get the cheapest energy when it's good for the grid. So these devices are going to communicate to the grid. At the moment, historically, they've been pretty dumb bits of plastic that are stuck on the side of a wall of a house. No connection. They're pretty independent. There's nothing smart in them. But when you talk about smart and you talk about smart on scale, so you have hundreds of thousands of devices on people's houses that are communicating to the grid, then cybersecurity ends up being really important from their perspective around grid fragility. If you were to attack hundreds of thousands of vehicle chargers at once, you could really cause some mess to the electricity grid. So yeah, I guess I come from the perspective of the need for the cybersecurity on those devices and on those networks that are communicating and providing the vehicle a service.
Interesting. So, Dominic, from your perspective, how are we trying to deal with these threats and challenges?
So for us as a traditional component supplier, it has become very important to learn more about the overall system, that you just also know the environment of everything, what is next to each other. And then obviously standards like ASPICE, the ASIL, the ISO 26262. So even for us as a, let's say, former dump component supplier, we have become knowledgeable. The whole ecosystem has become knowledgeable. How does everything work together, right? Even if you take a sensor and you take it out, if you put a bad sensor in, right, there needs to be a way of detecting what is going on. So an overall awareness increase. I think at this point, the threats of cybersecurity attacks are very well understood and known to everybody, but it's still this understanding, what does it mean on the system? And we have to really keep in mind the overall car, what is next to each other. That's what's been the big change for us.
Okay, interesting. So I have a final couple of questions, and maybe I'll start with Bernd, right? So Bernd, I'm sure in your capacity, you're privy to some interesting demands from the automotive world. Many of them would give you a kind of a perspective on what the future seems to behold in terms of both SDV or in general. So what do you think is the future, and how are we, looking at it beyond just SDV, etc.? Where do you see all of this going and, coming together to make things better? So just a quick view on that as well.
Yeah, I think what the next big step for me is the intermodality. So how do you integrate, individual traffic with public traffic, with any new development that's going on in the cities, with all the scooters? And so today is all individual, non-connected things. And I think the next big thing would really be the car manufacturers work together with all the other mobility providers and to offer an integrated system. And I think what they need to look at is that, and what they definitely will look at, where their business is and whether that's still a sustainable business for them. Because we recently saw a lot of examples where, for instance, Volkswagen, BMW, all of these guys started as mobility service provider, but in the end, it was not very successful. In the end, they sell hardware, and they sell software put into a device, more or less. This is their business. But I think the politicians and the local governments, they will put strong pressure on the car industry, and I think they've been forced to look at alternative integrated ways for mobility, and not only about the carbon emissions of the cars, because currently we are more or less focusing on that point of view. But if they become smarter and integrate more all the other means of mobility, then hopefully it will be a better world. And for that, it will even be much more a question of data integrity and a question of the whole data ecosystem then. Yeah.
Interesting, thanks. Dominic, one quick question to you. It's coming from the audience. We spoke a lot about software-defined vehicles, but does this whole software-defined concept actually help increasing the security or reliability of the automotive vehicle, or is it just an architecture that technologists talk about?
I wouldn't say it makes it easier. It might shift it, right? Depending if you have a good setup. You still have obviously entry doors where things come in. I think these entry doors have shifted, but it's not necessarily reducing the threat. I think there is much more awareness, and I think people will continue to try to use it for malicious attacks. We just have to be much more attentive. And also I think for us as an ecosystem, by keeping in touch and talking about this, that we keep that awareness and that we don't inadvertently, by chance, by something that we do, make it easier for somebody else to have an easier way in. So I think it's just the overall awareness, but it's not necessarily getting easier. No.
Interesting. Good. I think that's a interesting response, right? So software defined isn't the elixir or the answer to all the problems that we might have or all the challenges that we might face here. Great. So I think I will move to my final section. So Eve, I'll come to you. You can take this question and also, go ahead with the closing remarks and a word of thanks. So the question to you is, again, very forward-looking. What do you see beyond SDV, and what should we expect as the next automotive revolution?
So for me, SDV is the foundation of the new journey for the automotive. So we are just starting now to understand what is behind this. We are just starting to understand what will be the impact on everybody. So I think once you are moving to SDV, you are reducing also the entry costs for new companies. So they don't need to go for a complete system. They can go only for a part of this. It means we'll change a lot the ecosystem. We'll change a lot the way of thinking about a car. Once you go for SDV, this is what we were also discussing at the beginning. One of the purpose of SDV is adding value to your cars on a mid or long-term point of view. And this means also it will reduce the frequency of buying a new car in terms of material. So I think it will also change a lot of things in terms of sustainability, because you will focus on the software more than on the hardware. And it should also help the complete industry to change the way of thinking about a car. So I think behind this, you will have also a lot of new people having new concepts, new ideas. We're discussing a little bit earlier about this. We are still in a vehicle-centric way of thinking today. We are not really in the new generation for me, which is what is the business case? What is the use case? And how you can use a car in this business case? This is, I would say, an obvious way of thinking in many other industries, but still not in the automotive industry, because the cost to update your car were that high. The people were more thinking about a product which is a finite one, and that you have to deal with for 4, 5, 6 years, but not more. Now, changing the way of thinking will change the entire industry, in my view. And it will have impact on all of us, impact on our way of thinking about a car. Okay, so you will not anymore think also about a car like a huge invest if you are quite sure that you will get the money back. If the value of your car is not going down within 3 or 4 years, then the way you will finance it will change also.
Interesting.
So it means it will have an impact on everything, in my view, not only the technical parts, but also the business model behind this, also the way we are dealing with a car, the way we are understanding a car. And it means also for all the OEMs, a huge change in the way they are managing their business. Because if you are selling less car, then you need to think about how to make sure that you are still economically and in a business way, a strong company, meaning your business model has to change. The way you are selling your car has to change. Maybe the profits on the selling of a car has to be also adjusted, but you need also services afterwards. You need to make sure that you will still be a company which has a strong business model. So therefore, for me, this is a huge change. This is also a huge chance, because a lot of companies that were struggling today to start in the automotive branch with good ideas, but not enough invest capability, will be able to start now on this market. Of course, there are some very strong challenges. So we were discussing a little bit about cybersecurity, but you will also have an issue with litigations, warranties, who is taking the responsibility of a car if you are making an open platform for a lot of softwares. What about responsibilities in this? So it will open a lot of discussions, of course, but I think this is a very interesting journey which is starting now for all of us. And in my view, this is going deeper than the electrification. Electrification is, of course, a huge change for everybody. Electrification is, of course, a huge change in the technologies, but this is less a huge change in the automotive and the transformation of the branch.
Interesting. Any other closing remarks, Yves? Or
no, I think for me the closing remarks is it's really interesting to see all the different angles that you may have for the SDV, the dynamics that is behind this, the passion also of the people speaking about this, and this is also what I'm facing each day, discussing with people that are dealing deeply with SDV. Is almost always having a passionate discussion. And I think it will be even more if you go deeper, if it's an open system or is it a proprietary system. So you have a lot of opportunities to discuss about this. And this is always a pleasure to have this kind of discussion.
Great. Thank you. I think we've had a very, very interesting discussion, and I'm sure we can go on for a very long time. But we'll just kind of summarize the key highlights, just as Eve mentioned. Lots that I learned today. So I can maybe give it back to Natalia for the final word of thanks and for a summary. Take it over, please, Natalia, and help us close this.